Hi. Welcome back. This is the last one for the day, but it's equally exciting as the previous ones. So for this one, we are going to be talking about a common problem for mobile apps. How do they work in poor network conditions or in non-network conditions? And the solution that we have for you guys is something that Ilya spoke in his keynote, a new feature called the Local Datastore. And the next speaker is going to be talking about that in more details, as well as how you can productize your app a little bit more by introducing secure features that will protect your data and that of your users. So Brian Klimt is an engineering manager with the Parse team. He's leading the platform API there. And he's also the main contributor of the open source Bolts library that we talked a little bit about during the Applinks discussion. So I would like to welcome Brian on stage, and he's going to take it from here. Thank you.
Thanks. Hi, I'm Brian, software engineer from Parse, and I'm here to tell you today to tell you how you can make your Parse app more robust. And robust can mean a lot of different things. So what I'm going to tell you about is how you can make your app work everywhere, how you can make it more secure, and how you can make it scale better. So let's start with how you make your app work everywhere. Normally, when a software engineer from Parse says we can help you make your app run anywhere, we're talking about how we have SDKs for iOS, Android, Windows, Windows Phone, Unity, JavaScript, you name it. Today, that's not what I'm talking about. And to tell you why, I'd like to tell you a little story. Back when Parse was just a tiny startup, we were here in San Francisco, but I lived down on the peninsula. And that meant riding the subway into work every day. And the thing I noticed when riding the subway into work was that whenever the train would go into a tunnel, many of my apps would stop working correctly. And that's not universally true. There were some apps like Candy Crush where I could play the game just fine in the tunnel, and then when I would come back out of the tunnel, it would sync. But for the most part, my apps just completely started failing. And I would love to just be critical of these app developers and say they're doing it wrong, but the truth is I was just as guilty of that myself. When we designed a lot of the original Parse APIs, they were designed around the idea that you would always be connected to the network, and you could query data straight from the network, save it right back. And while we have introduced a lot of features like save eventually or query caching that make it easier to function when you're offline, they're always kind of add-ons, and they weren't really a core part of the API. So I was thinking about how we could fix this, and I went to my manager, Kevin, and I said, wouldn't it be great if we could just make all of the regular Parse APIs work when you're offline just as well as when you're online, without developers really having to do anything or think about it? And but it's too bad. That's impossible. We could never actually do that. And Kevin gave me his signature skeptical face with his eyebrow really high raised, and said, "Are you sure that's impossible?" And so today, I'm glad to be here to tell you that I was wrong. Actually, that's exactly what we've built, and we're calling it the Parse Local Datastore. It's available today in our Android SDK, and it'll be available in our other SDKs in the very near future. The idea behind the Parse Local Datastore is simply that your app needs to tell our SDK which objects it wants to be available at all times. And then once those objects are available, all of the regular Parse APIs, including querying and security, et cetera, all just work. So the core of this is how do you tell the Parse SDK which apps you want to be available when you're offline? You do that by pinning them. So some of you may recognize this code snippet. This is straight from our website, how you save a game score object that has a player's name and their score, the fact that they weren't cheating. On our website, this example uses gamescore.saveinBackground because it's showing how to save an object to the Parse cloud. But in this example, instead of save in background, we're just calling pin in background. And what pin in background does is it says, this object, I want to be available on this device at all times. And that's really all there is to it. Of course, as with all of our save methods, there's also callbacks to let you know when it was done. And that pretty much covers how to tell us that you want an object to be available, how to store it in the local data store. But the next question is, how do you get an object back out? And there's a couple of ways to do that. So again, you may recognize this example from our website as our first example of, if you know an object's object ID, this is how you get it out of the parse cloud, by fetching it. You do a get in background with a parse query of the correct type, in this case, the game score type. Now, this is literally how you get it from the cloud. In order to make this fetch data instead from the local data store, all you do is this. Call query.fromLocalDataStore. And that tells the query to search over the objects that are available on the device itself, including any changes that you have made and not saved to the server. Now, a lot of times, obviously, you're not going to have an object ID, especially if you just created this object. So you won't necessarily do a get in background, but parse queries support from local data store for any parse query. So even if you don't know the object ID, you can select specific search criteria and pull up exactly the set of objects that you want, as long as they've been pinned. Then, when you're through with an object, not surprisingly, all you have to do is say unpin in background. And what that does is it tells the local data store, I no longer care about this object being available on the device. You're free to remove it at any time. So that's pretty much all there is to the local data store API. I'd like to dig into a couple of very common use cases and how you would use it. And the first one is, how would I use the local data store in order to cache query results? So in this example, I'm creating two queries. These queries represent high scores that you would store in a game. So the first query says, I want to get all game score objects by descending score. That's like the global high score list. And then the second query, you'll see there's an equal to friend with a particular current user. And that says, I want to see just the high scores for my friends. Now, in each of these queries, in the callback, when the query's done, we're just calling pin all in background and giving it the list of scores. So just like we have helpers for save all in background and fetch all in background, we also have pin all in background that lets you save many objects at one time. And so that makes it very easy to take a set of objects that you've gotten from a query and cache all of them. So now, if you ran these exact same queries but said query.fromLocalDataStore, all of these objects would be included with no extra work. Now, besides pin all in background, there's actually one other thing I want to point out here, and that is there's actually a problem with this code. And that is, what if one of my friends happened to also have a globally high score? Using pin in background and unpin in background, just like you've seen here, is a lot like using free and malloc for managing your memory. It's a really powerful abstraction. It lets you do what you need to do, but for complex scenarios, it makes it really hard to manage which objects are available and which ones aren't. So in order to address that problem, we've added the concept of labels. When you pin objects, you can attach a label to it, and the objects will be added to the pin with that label. So in this example, we've labeled the two times that we pin. The first time, we apply the label global high scores, and the second time, we pin with the label friend high scores. And so this accomplishes a couple of things, but the one that I want to point out in this example is that when you remove objects from one pin, say when you use the helper to unpin all global high scores, since your friend was also pinned as a friend high score, this won't remove them from the local data store. As long as an object is pinned with at least one label, it'll stick in the local data store. So this makes it really easy to cache different queries that may have overlapping objects and still have full control over what objects are and are not in the local data store. So this is actually a really powerful way to do local caching. And I'd expand this a bit to say a really good strategy for doing query caching with the local data store is to develop your mobile app where whenever you're populating a user interface, you do a query just against the local data store. The local data store can get data from two different places. One, you can occasionally run a parse query against the network that populates the local data store. And you can also take any changes that the user has made in the mobile app and store those directly in the local data store. So that way, when your UI does the query against the local data store, it includes both the data from the network and the locally made changes. So it makes it really easy to merge network and local results together. One of the things I really like about this approach is that in this diagram, there's these two arrows labeled query. These queries can actually be the exact same parse query. The only difference between them is that the one on the right is from local data store, and the one on the left isn't. So that takes care of how I get data from the cloud into the local data store. The only other piece is how do I get data on my device back into the cloud. This is the fetching. How do I do the saving? And there's a couple of different ways to do that. I like to think of them as manual and automatic. So the automatic method, really simple. For those of you who've used Parse, you know about the save eventually method. So save eventually says, I want to take the changes to this object, I want to store them on the device, and then the next time the network is available, I want to take those changes and apply them over the cloud. With the Parse Local Datastore, not only does save eventually work, it actually gets superpowers in a sense. So when you save eventually an object, it also pins it in the local data store until it can be saved. So then if you run a query against the local data store, you get all of the changes that have been saved, even if they haven't made it to the cloud yet. This is particularly useful for the current user or the current installation. With the previous implementation of caching, if you called save eventually to save changes to a user, you wouldn't be able to see those values change when your app restarted until the next time you fetch data from the cloud. But with pinning and the local data store, you will see any changes that you've made to the current user whenever you fetch it. So that's the automatic method. As I mentioned, there's also the manual method. So manually syncing from parse queries is really good for situations where you maybe have a game where everything can work offline, and maybe you let the user log in with Facebook in order to sync with their Facebook account. You don't want to use save eventually because you want to wait until the user actually signs up before saving their data, and until then you just want to keep all of the data locally. So in order to do that, you just need to write your own syncing function that you run when it's time to sync. And all that syncing function needs to do is get all the objects from the local data store that need to be saved and save them. This is the very simplest use case where you just get all of the objects, all of the game score objects, and call save on them. It's pretty safe to do because if an object hasn't been saved, then save in background just won't do anything. But if you've got a little more complicated scenario and you want to sync some objects and not sync others, or maybe you just have a lot of objects in the local data store and don't want to query for a bunch of objects you don't need to save, you can also use a label for this. So with a parse query, you can say from pin and give it a label, and then it'll search just over the objects that have been pinned with that label. So that lets you, whenever it's time to save an object, you can pin it with my changes label, and then later, this function can come along, query for all the things that have been pinned with that label, call save on them, and then when they're done saving, you can unpin them from that label. So that's everything you need to know to get data into and out of the local data store. The only other thing I want to mention is that all of the Parse Security features just work with the local data store. So a very common use case that we've run into is something like games, where people use Parse in order to store game assets like level design, stuff like that, that is going to be available for all the different users. But they also have game score data that's specific to a particular user. And just because a user logs in, that doesn't mean you want to clear all of the game design data, the level data. But when they log out, you don't want other users to see their data. So in order to make that work, the Parse Local Datastore, when you query against it, respects all of the Parse Security features, like access control lists and roles. And I'll talk a little bit more about that later. But speaking of security, I'd like to tell you a few things that you can do to make your Parse app more secure. So first off, one of the most common questions we get about Parse Security is, hey, if I'm building a Parse app with the JavaScript SDK, can't any user come along and click View Source and pull my JavaScript key out and access all the data for my app? And actually, that's true. I mean, the client keys, like the JavaScript key and the REST key and the client key, are not intended to be security features. I'm going to say that again just to really sink it home. They're not even intended to be security features. Last year at our Parse Developer Day, when we open sourced the Parse Developer Day app, we left the client key in the open source code because we believe in the rest of our security features, which can allow you to make your app secure even when giving the client key to your users. I should note the one exception to this, and it's a huge exception, is the master key. So the Parse master key lets you override all of the normal access controls. So you want to guard that really closely. You don't want to check it into version control. You want to treat it just like a root password on one of your servers. So given that clients are going to have a client key, there's a lot of different levels of features that you can use in order to secure your data. And it starts at the top level with class level permissions. So this is a screenshot from the dashboard on parse.com. You can go to a particular collection and click on Settings and get to the class level permissions. And I'm just going to go through a couple of these permissions to explain why you might want to enable them. So at the very top, there's the get permission. And what that does is it says who is allowed to get the data for an object from Parse, given that they know its ID. As you can see on the right, the dialog that comes up when you click on the get permission, there's several different options that you can choose for this. One is the checkbox, can any user perform this? So if that's checked, then literally anyone can get data for an object. And so for something like the Parse Developer Day app, where it's all public data and anyone should be able to access it, we leave that box checked. If you uncheck that, then no one will be able to access it, except for the people that you list below. And so below that, you can list both specific roles, which I'll talk about later, and also specific users that you want to be able to access this data. Likewise, with the find permission right below it, it works very similar to the get permission, except it's who can query your data in your table, even if they don't know the ID of a specific object. Now, I'm going to skip down to the bottom and then come back. The last one, the add fields permission, is a little bit strange. So normally with Parse, we take objects when you save them and look at the types of the fields that you're saving, and we use those to infer a schema. And we really like this because it lets you develop your app without predefining a schema on our website. We just learn it from the data that you're saving. But once it's time for an app to go into production, you usually aren't going to need your app to be able to add new columns to the data. So when an app goes into production, you almost always want to go into your class level permissions and disable the add fields permission. All right, so I want to go back up to these other three, update, create, and delete. They're pretty much what you'd expect. For something like the Parse Developer Day app, where no developer is allowed to change, or no user is allowed to change the data for the schedule, we disable update, create, and delete. But if you have an app like Game Scores, where a user has their own game score data that they might want to create or delete, then you need to leave this enabled. So the next question is, if I've enabled update, create, and delete permissions, how do I secure specific objects that belong to those users so that only those users can access or change them? And to do that, we have access control lists, or ACLs, or ACLs, depending on how you call it. So with a Parse ACL, you can set specific users or roles and give them either read or write permission. In this particular example, again, straight from our website, you can create a note, you can set whatever content you want on it, and then you can set a new access control list that's just for the current user. So with this constructor, what it does is it takes that user and says, OK, only this user is allowed to read or write this object. And then once you save it, no other user will be able to query for it, no other user will be able to delete it, et cetera. I think the most common confusion that people run into when they try to use access control lists, because really for user data you should always use access control lists, but the biggest excuse people come up with to not use them is they say, well, what if I want some of the user's data to be private, but I want other data to be shared with that user's friends? Don't I need to make the whole thing open? So So I'd like to dive into a little bit of detail about strategies you can use to get around that. So the first thing to know is that rather than setting different access controls for different fields in an object, you can use one-to-one relations to break apart your data based on how it should be shared. So in this example, I've got two objects. I've got the user object, which can be secured so that only that user can see it. Only they can read the private this or private that fields. And then it has a pointer to friend data. And this friend data has data that obviously this user's friend should be able to see. And it has an access control list for a particular role. And I'll explain what roles are in a minute. But in this case, this role represents this user's friends. So by setting this role to be able to read this friend data, only this user's friends will be able to see it. So let's go into what roles are, since I just used them. Here's another code snippet that creates a role and sets up this friend data object. So actually, step back a bit. This actually sets up an admin role. So this is a little bit simpler example. We create a role, we call it admin, and then we create an access control list such that we set public read access. So in this particular example, this is an object that anyone can read. And we set write access to just this particular role that we've just created. So this basically says anything secured with this access control list will be visible by anyone, but can only be modified by people who are in this admin role. And then at the bottom, we've set up an object, which in this case is a physics model, say for your game, where you have a constant for gravity. And so any client should be able to read the gravity constant, but only admin should be able to change the value of gravity. But to go back to the friends example, let's talk about how we would set up a friend role so that only your friends could read your data. So what we see here is a piece of Parse cloud code. So for those of you who missed the earlier talk and don't know what cloud code is, it lets you upload JavaScript to Parse's servers that we run on your requests. In this case, it's an after save handler. So every time a user gets saved, we then call this function in JavaScript. So starting from the very beginning, we get the user that was just saved, and we say if user.existed, return. So the existed method is really useful in after save handlers to check whether or not this object was just created. So by saying if user.existed, return, we're saying, OK, everything after this, we just want to run the first time the object is saved. And after that, we can just stop here. So moving on to the part that's highlighted in yellow here, what we're doing is the first time a user is created, we create a role name that is friends of and that user ID. And then we create a role. In this case, there's an access control list assigned to the role with just that user, meaning only they are allowed to change who's in this role. And then we save that role. Then once we have this role that represents this user's friends, we can create a new access control list that sets only read access for that role. And then we can create this object that represents the friend data. We can put whatever data we want in it, and then we secure it with that access control list. And then we save the friend data. So what this does is every time a user is created, it automatically sets up that one-to-one relationship, and it sets up all the access control lists and the roles so that they now have both their user object and a friend data object that is public to just people who have friended them. So the other piece of this puzzle is, OK, how do I add friends to this role? So in order to add a friend here, I've defined a cloud code function. So what a cloud code function is kind of like an after save, but instead of being triggered by saving an object, you can just invoke a function directly. So if you're using one of our mobile SDKs, you can call parse.cloud.run, pass in the name of the function as friend, and then pass in arguments. In this case, as you can see from the second line, request.params.friendID, you can pass in a friend ID to be friended. Then, again, we set up the exact same role name. We query for a role with that name. And then once we get that role, which represents whose friend I'm going to be, then we add the user who was passed in to the users for that role. And that's it. So I think this is a pretty common pattern. In general, you can use Cloud Code to implement a lot of security features. And one nice thing about that is it's kind of like an escape hatch or escape valve. So anytime there's a case where access control lists or roles almost work, but there's one case where it just doesn't quite fit for your app, you can write Cloud Code that uses the master key in order to talk to Parse, and it can override the security. But it does so on our servers with code that you've uploaded, so it's trusted code. OK, so that's basically the whole security story. And next, I'd like to talk to you about how to make your app scale. And if you only listen to one part of my talk, it should be this part, because it's the only part left. Actually, I'm going to go back to that. So making your app scale on Parse is mostly about making sure that your queries are performant. And making sure that you write good queries is kind of a dark art, because it requires sort of thinking about how efficient we're going to be able to make the query, whether or not we're going to be able to index on the particular fields that you're searching for. So I can't give you a silver bullet for any kind of situation, but what I can do is give some rough guidelines. So when you're writing a query, you can make it more efficient by making it as restrictive as possible. So for instance, if you use an equal to field, or an equal to constraint on a query for a field that has a lot of distinct values, then we can index that very efficiently and pull out exactly the row that matches that field. On the other hand, if you use something like a not equals to, well, not equals to matches almost everything in your database. So just matching the not equals to means we still have to iterate over all the items in the collection. So in general, it's good to make your queries as restrictive as possible. The two biggest problems we run into where people aren't sure how they can achieve what they want while still making their query restrictive are counts and searching. So in the case of counts, if you run a normal query over, say, everything in your collection, we can iterate over the first 100 items or something and return it if it's just a regular query. But if you do a count query, we've actually got to iterate over everything in the collection that matches in order to actually count all those items. So if you've got 1,000,000 rows and you do a query with some parameter on it, we've actually got to iterate over 1,000,000 rows in order to see if they match. And that becomes inefficient very quickly. So there's actually a different strategy that you can use to make count queries work better. And that is what you see here. So I've added two Cloud Code functions here. The model here is that you've got a situation where users can like items, let's say. And the way that they like an item is they create a like object, they set themselves as a user on it, and they set the particular item that they are liking, and then they save that. This is a really good, secure model for this because it means users control their likes. They can delete their likes and create them without them having to have write access to the original item. But the trick here is whenever anyone saves a like, we then go grab the item that they liked, and we increment atomically this likes field on the item. And then we save the item with this special override. So I mentioned earlier, you can use Cloud Code to do requests using the master key in order to bypass the normal security mechanisms. So in this case, we're saving the item, and we're passing the use master key true option. So this option exists in Cloud Code for any request that would talk to Parse. You use it on queries, you can use it on saves, everything. So by doing this, we are restricting the item so that normal users can't update it, but with Cloud Code, when they like something, it can increment this one field. And likewise, we have a before delete handler, so whenever anyone deletes a like, we can go in and increment likes by -1, also known as decrementing the likes, and then we can save that. So when it's time to find out how many times an item has been liked, instead of having to query over the entire like table with a count query, we can just grab the item, and it already has the counts pre-computed on the object. So it's way more efficient. It's just one request. So like I said, counts are the most common case of, or one of the most common cases of inefficient queries. The other big one is search. So a lot of people try to do search using regular expressions. And regular expressions are pretty terrible efficiency-wise. There's no good way to index a collection in a way such that an arbitrary regular expression can be efficient. So if you want search, you have to do another similar trick of pre-computing data. So I'm going to start with this particular example. I don't want to go into this in too much detail, but you have to write a tokenize function. And what this tokenize function will do is normalize the search text that was entered or the text that's going to be searched into just a set of normalized words that you can search for. So in this case, it's using the underscore library. I highly recommend learning underscore if you're writing any amount of JavaScript. It makes things way easier. And this function takes text, it lowercases the text, it splits it apart on word boundaries, and then it removes anything that only has punctuation in it. So what this does is, like the comment says, it takes a string like this is a string with capitalization and punctuation, and it returns an array that just has the normalized words in that string in it. OK, so this is just a helper function, but it makes the next two steps a lot easier. And those two steps are first, search indexing. So I put it in quotes because you don't really have to do indexing here. All you have to do is use another Cloud Code, in this case before save handler, that takes a post, takes the text on the post, tokenizes so you get that array, and then it sets another field on that parse object called words that is that array. So now the post has both the original text field that's a string, and it also has the words field that's the array of the words. And the reason I call this indexing is that when parse sees that you've saved an object with an array field, we can index the individual elements in that array so that you can search for them efficiently. So after you've done this very simple indexing phase, all you have to do to search is do a simple query with a contains all. So in this case, I've implemented this as a Cloud Code function just for consistency with the presentation. But you could just as easily implement this in the Android SDK or in the iOS SDK just by using a query that searches for all the words. So what contains all does is we take the param text, whatever's being searched for, we break it apart using the exact same tokenize function. It's important to do that so that the text is normalized when you index and when you search. And then we do a query for any item, any post, where the words array contains all of the words that are in the tokenized text. And so this lets you solve most cases where you want to do free text search in a much more efficient way than regular expressions would. And then finally, the last thing to think about when trying to make your app efficient and scalable is how you should model your relations. So Bear touched on this a little bit in the last talk. If you go to Parse's documentation, there's a section called the Relations Guide. And the Relations Guide goes into way more detail than I'd be able to talk about in my presentation today. But it helps you pick which representation of one-to-many or many-to-many relationships will be most efficient for your use case. And I'd say the high points to think about, going into it are how many items are on each side of the relationship and how are you fetching them. So if you've got a one-to-many relationship where it's, say, followers of a really famous person and you might have 1 million followers, you're not going to want to store an array on an object with 1 million items in it because your object will be too huge. It'll be really inefficient to pull it down from the network, and it may even be too big to store in the database. So in cases where you have a one-to-many relationship where the many is very huge, or even a many-to-many where the many is, one of the minis is very huge, then you would use a parse relation. And since that uses sort of a join table approach, it's going to be much more efficient for a large number of items. On the other hand, if you have a very small number of items and you're always fetching them from one side, so for instance, if you're always fetching my object and my friends together, then you could use an array there, and then the reason that that would be preferable is that when you fetch myUser object, with the query you can do what we call an include. So you can say include key friends, and it will automatically fetch the data for all of my friends too and include those in the request. So what that means is you can do one query that gets data not only for the root object, but also for the objects that it points to, even if they're in an array. And so then you're just making one request. And so depending on your particular use case, that might be more efficient. And then finally, pointers. If you have a one-to-many relation, you can use a pointer on the side that's pointing to the one. And depending on which side of the relation you're trying to search from, that might be more efficient. So that's all I have prepared, but we have about 10 minutes left. I'd love to take whatever questions you have about Parse.
Man in the front.
There's an ability to mark certain apps as production and not. What does that, besides just labeling it, does it actually do anything as far as resources and stuff like that?
I don't actually I don't actually know the detailed answer on that. I think it's mostly for labeling at this point, but on both ends, so not just for your labeling, but also so that we can see what apps are in production and which aren't, which helps us learn about trends and figure out how we can make those apps more reliable. I think we definitely want to be more aware of what apps are in production and which aren't, and so that may change in the future.
Question here.
Thank you. We love Parse.
Yay.
So when you call save eventually to commit something from your local data store to the server, is there any way to know when that data gets committed?
If you call, right, so if you call save eventually, is there a way to know when the data is committed? Thinking about this. If your app has not restarted yet, if your app has not restarted yet, then you can pass a callback to save eventually that will be called when it's completed. If your app has restarted, I don't think there's a way right now to know when it's been committed.
It would be nice to have a way to reinstall the callback or to get some sort of notification.
Right, right. I could definitely see how that would be useful. I think we'll think about whether or not we could add something like that.
Thanks.
So especially like the new pricing model, good stuff.
Great.
I wonder why is it that you had to leak the abstraction when you showed the example for local data store where you said query dot in local data store? Couldn't that be inferred automatically? Why do I have to tell you that, tell Parse that I want the query to be in a local data store? It should figure out that the data is newer in the local data store and then give me that or fetch it and also realize I don't have a network, therefore I should just go local.
So I think at this point we wanted to build sort of the low core abstractions that would work for every scenario. So we wanted it to be clear that you could separately fetch from the network when you want to get new data, or fetch from the local data store when you specifically want cached data. I think as we move forward into the future, we'll be thinking more about how we can make things more automatic. But right now, it's just a little bit more of a manual step.
Question here.
In your example with the liking an item, and you had after delete, you decremented the likes on that item.
Right.
The question is, when I go to delete that item, the user decides they don't want that item up anymore. I want to go delete all those likes out there.
Right.
You know, in a separate activity table, but they're hitting against, they're trying to decrement an item that no longer exists. Is there a way to suppress that after delete, or is it just trying to increment against a null object?
Right.
Okay.
So that was actually a before delete. I was trying to go back to the slide, but I can't, in case you're wondering why I'm clicking here. So in a before delete, you can choose whether or not to allow the delete to happen. I just wanted to point that out as a security feature. But in this particular case, so it uses promises. So I don't know if you're familiar with JavaScript promises, but when you call the save to update the item, it's going to then call a callback either on success or error. And so if there's an error there, you can just handle that error, and the delete will go ahead and proceed. I don't know if that does that answer your question?
Just make an API call. Oh, sorry. Yeah, it was just making API calls for deleting every one of those activities.
Right.
Null object. So.
We don't have a batch delete function
Yeah.
right now, except through the data browsers.
Okay, thanks.
Question over here.
How does the Parse Local Store, when it comes out on iOS, interface with core data? And are there any best practices right now for using Parse with like a system with core data?
Yeah, so the local data store is not finished in iOS, so I don't know exactly how it would or wouldn't interface with core data. It's probably more likely that it would be built on top of SQLite. When we've looked into integrating with core data, there were a few assumptions that the core data API makes that are not necessarily safe assumptions for a Parse app. In particular, the core data API really likes to go create IDs for objects even before data has been saved to them. And so what that means is that if you use core data to sync your Parse data, then your app is going to have to deal with the case where you may have created objects but not populated them with data yet. And so as long as you're aware of that and willing to code around it, you can use core data. But it may not work for every situation.
So I know that it's semi-related question to that, but I know that the intended use case is for, like if you have a bad network connection or no network connection. But for iOS, would it be acceptable to use it as a local persistent storage method? I mean, like,
absolutely,
rather than core data, because core data is a mess?
No, absolutely. I mean, I don't think the intended use case is solely for when you don't have a good network connection. Like I use the example of a game like Candy Crush where you store all your data locally, and then if and when the user signs up, then you sync it to the cloud. You can absolutely use it like that. We would encourage that.
Okay, is there any ETA on the iOS?
There is not. I just want to say the reason that it's Android first is we felt this was really ambitious to make such a simple API that works everywhere. And so we wanted to focus on one platform and get it out the door and prove to ourselves and everyone else that it works. And now that we've done that, we're going to take it to the other platforms as fast as we can.
Hi. A couple of questions. I didn't see user objects in any of the examples. How does local storage work with user objects?
User objects are just Parse objects,
Okay.
so they all just work in the local data store.
Okay.
There's no difference.
And then the second question is, when you call save eventually, say on the client side, if you've lost network connectivity, theoretically, that could happen multiple times. Ultimately, does that translate into a single save request? And if so, how does that affect, say, a before save validation on the server side that assumes an invocation each time that
Right.
the object is
So
saved?
we actually have a really sophisticated mechanism for tracking sets of changes in Parse objects, and I can't really get into the details of that. But when you call save eventually on an object, it takes the changes that you've made since the last time you saved, and it puts those somewhere to save them later. And then if you change the object again and call save eventually again, it'll take that and make it a separate batch of changes to be saved later. So it actually will invoke your before save or after save handlers multiple times with the individual changes. The only time it gets tricky is if you reject a save or have an incorrect schema type so that a save gets rejected, then we don't want to throw away that data, so we might roll forward those changes into a subsequent save. So there are some tricky cases there if you have cases where saves fail. But if it's just a network problem, then we keep everything segregated and everything should work fine.
Thank you so much, Brian.
Thanks for your time.
Thanks, everybody, for staying up until now. Thanks for attending the event. Thanks for being here with us. Hope you learned interesting stuff. It's time to hit the bar. Bye. See you next year.